With part 2 that we have here, it is a loci question, but yet it is not like any of the standard locus that we have drawn previously. What we are supposed to do is on the spot, we are supposed to interpret, analyze and sketch the locus of Z and then the locus of W. Let's take a look at Z first. For Z, it has a modulus of R, and it has an argument of theta. R is a constant. That means Z is going to have that fixed distance R away from the origin. Its modulus. But for theta, theta varies between 0 to half pi. So let me try to work out one possible position of Z. One possible position of Z can be, let's say, here. If I were to say Z is here, that means the distance that this point is away from the origin, it is going to be R, and this angle here, it is going to be the argument of Z, it is theta. Other positions of Z, is going to be all the same distance R away from the origin, but theta is going to change between 0 to pi over 2. So another position, maybe it is here, this distance here is going to be R and this argument here is going to be theta. If I were to join all the possible positions of Z that I can visualize on this Argand diagram, can you see that Z is going to take up the circumference of a circle with the radius as R, and the origin is going to be the center of that circle. So if I were to replicate what I've understood there about Z onto the actual Argand diagram, it is going to be two of the endpoints will be, one is here, the other one is here. The one that is here, let's say, let me draw it here. I'm going to use a solid dot, because the endpoint can take up the value of half pi. So for this endpoint, it is going to have a modulus of R and an argument that can be equal to half pi. So here is half pi. The other possible position, which is this other endpoint, it is when theta takes up the value of 0. So it is going to be on the horizontal axis, where it has a modulus of R. So let's say it is here, modulus of R, and the argument is 0. Like what we have discussed, all the other positions of Z is going to be in between here with a fixed distance of R away from the origin, and as theta varies from 0 to half pi, it is going to form for us that it is going to be falling on that circumference of a circle. So that circle, let's say it is like this. So this is going to represent for me the locus of Z. Next, let's take a look at W. For W, it is definitely going to be reference to Z. In fact, the distance that W is away from the origin is twice the distance of Z is away from the away from the origin. So if let's say this is that Z value, so W is going to be the modulus of W is going to be R and then one more R, because it is 2R. So the modulus is going to be 2R, and the argument is the argument of Z turn by pi over 3 clockwise, by minus pi over 3. So the argument of W is going to be, what I have for Z, which is theta, turned by pi over 3 in the clockwise direction. So the possible W can be somewhere here, where it is turned by pi over 3 and the modulus is 2R. So if I were to look at W and if I were to try to analyze this idea for all the possible positions of W, W will also be sort of like lying on this other circle, this other circle with the radius of 2R, and the center of that circle is always going to be the origin. So by making use of this idea, again, let's try to sketch it on our same Argand diagram here. Let's focus on the two endpoints first. I'm going to look at when Z is when theta for Z is at half pi. So when it is at half pi, W will be of course twice the distance 2R, and it is going to turn by pi over 3. So a possible position for W can be somewhere here, let's say. This distance here is going to be 2R, because this is R, so 2R, and it is going to be turned by pi over 3 according to this endpoint. So the end of W can be somewhere here, and the argument is going to be pi over 2, half pi, minus away pi over 3. So this is going to be pi over 6, okay, as the one of the endpoint of w. Okay, the other endpoint of w, I'm going to reference it to when the argument of z is equal to 0. So the distance is again 2 times, okay, and it is going to be turned by pi over 3. Okay, so the other endpoint of w, okay, it will be r and 2r, okay, r and r. Okay, this is the other possible position of w. Okay, it is going to be turned from here by an argument of minus pi over 3. Okay, and like what we were saying, it is going to form for us, w is going to fall on that circle, okay, a circle with center at the origin and the radius of 2r. Okay, so the possible position of w will be lying here, okay, and this is going to form for us the locus of w. Okay, so it is this portion over here.